are just solving the inequality. Okay, we spent a few days talking about solving the inequalities. We solve them just like equations. We're going to isolate the variable, get the letter by itself, okay, by doing opposite operation to move things across to the other side. Okay, and then once we have that, we'll take a look. Since it's not an equal sign, it's an inequality sign. What does that mean? And we'll put it on the number line to represent what our answer comes out to. Okay, so I'm going to separate the left and right with the line. Okay, I want to get x by itself. Right now there's only x on the left side. Okay, so that's good. I don't have to move any x terms. I'm going to start by moving that 8. Okay, we use opposite operation. So the opposite of +8 is -8. And what we do to one side, we have to do to the other. So our 8s eliminate on the left, which leave us with 4x is less than -12. Okay, now that 4 is being multiplied by the x, so this opposite of multiplying by 4 is dividing. So we're going to divide. What we do to one side, we do to the other. So the 4's reduce, and that leaves us with just x on the left. Our inequality stays a less than symbol. Remember, we talked about last week, when we're solving, if we multiply or divide by a negative, then we have to flip the sign. We didn't multiply or divide by a negative, so our sign didn't change. And then that's -3 on the right. So I end up over here, I'll write this and box it in, x is less than -3. Now when we go to put that on the number line, we're going to put a point at -3. Remember, the choice is either an open point or a solid closed point. Okay, who remembers how we determine if it should be open or closed? This one is a circle, but how do we determine that? How did you know that? It doesn't have the or, yeah, that or equal. If you want to jot that down at the top, remember, if it has the or equal line underneath it, that's when we do the solid point. If it doesn't, if it's just less than or greater than, that's when it's the open point. Okay, that's what we talked about last week. So for this one, there's no or equal, so we have an open circle. Now the shading, we shade to the left or the right, depending if it's less than or greater than. Okay, remember, this is your less than symbol. And if you have your inequality where your variable is on the left side, remember how I talked about the inequality is kind of like an arrow? It's pointing to which side you should shade. So it's pointing to the left. So less than is to the left. Less than and left both start with L. That's another memory trick for knowing which side to shade. All right, number 2 is slightly more complex because we've got P on both sides of the inequality. So I'm going to draw that line to separate the left and right side again. I need to get rid of the parentheses on the right side to start. So this, whoa, sorry, that zoomed out like that. This 5 outside the parentheses is being multiplied, so it needs to be distributed. So the 5 times P is 5P, and the 5 times 2 is 10. Nothing's changed on the left side, that's still 5P, our inequality is still a greater than. Now I need to get the P's to the same side. Okay, ideally, I've been telling y'all I would try to always move my variables to the left side, so when I read my inequality, it makes more sense. So when I move the 5P by subtraction, what happens here on both sides this time? Yeah, the P's cancel on both sides. Not only did they cancel on the right that I was trying to move them away from, it also cancels on the left. That means there's nothing left over here. It's a 0. And on the right side, it's just the 10. So remember, we talked about if this happens, if your variables eliminate and you're just left with numbers on both sides, you have to decide, is this a true statement or is it not true? Is 0 greater than 10? No, 0 is not greater than 10. So this one is not true. So what does that mean when the statement that you're left with is not true? What does it mean about our solution? There was two possibilities we talked about in our notes last week. When the variables cancel, you're either left with a true statement and it's all real numbers are solutions, or you're left with a not true statement. And what? What does that mean? There it is. So Brianna said no solution, because this tells us there is no value, no number could be plugged in for P and it would make this original inequality true. Nothing would make it true. It will never be true. So there is no solution for this one. And so there's nothing to graph on the number line. You just leave the number line blank. There's no solution. All right, on number 3, I'm going to separate the left and right hand side. The A is our variable this time, and it's only on the left. So I don't need to move the A's anywhere, but I do need to move this -8 that's being divided. So what is the opposite of dividing? Multiplying. So to get rid of divided by -8, the opposite is to multiply by -8. And what I do to one side, I do to the other. Now on the left, the point of doing that was for it to eliminate, for it to reduce, which it does. But there's a special rule that we talked about. When you multiply or divide by a negative, what happens? The sign needs to switch. So this less than or equal needs to flip to greater than or equal, because we multiplied by a negative. If you multiply or divide by a negative, we have to flip the sign. Okay, and my -3 times -8 came out to +24. So remember, a negative times a negative is a positive. So I've isolated the variable. It's on the left side. That's my solution. My solution is A is anything greater than or equal to 24. So on the number line, I plot a point at 24. Is this one going to be solid or open? Solid, because it has the or equal. Very good. So I'm going to put a solid point at 24. And then it's greater than. So am I going to shade to the left or the right? To the right. Good. This, again, means anything 24 or greater could be plugged in for A, and that would make this a true statement. So I could plug in 24 or anything greater for A in the original inequality, and it would be true. So if you have a multiple choice question that has the graph and you're not sure, like your choices are the graphs and you're not sure which one it should be, you can always just pick a point from the shaded region, the shaded part of the number line, and plug it in and see if it makes it true or not. Okay, so that's a way you can work backwards sometimes if you're given the graph. All right, what about on number 4? Number 4 is a little more complex. We've got multiple variable terms on the same side, so we need to combine like terms. Okay, so I'm still going to draw my line to separate the left and the right. So on the left side, I can combine the -4m plus m. So that gives me -3m. And I can combine the 9 and the +4, because those are both constants. Okay, so if I combine those, I have +13. And my inequality stays greater than -17. So now Like terms are combined, it's simplified. I'm ready to start moving terms. What needs to move away from the M first? The constant. Anytime there's a number without the letter, that's what we move first. So it's plus 13, so the opposite is minus. And what we do to one side, we do to the other. You got to keep that balanced. So we've got negative 3m on the left is greater than, and then that becomes negative 30 on the right. Now, how am I going to move this negative 3 that's being multiplied by m? The opposite of multiply is divide. Remember, we're doing opposite operation to move the terms. So the negative 3 is reduced to get m by itself. Okay, and again, I've got a negative divided by a negative, which gives me a positive. And here's that special case again. We multiplied or divided by a negative, so our inequality has to flip. So what was greater than, it's got to flip to become less than. So m is less than 10 is our solution, and we have to notate that on the graph. So at 10, is there going to be an open or closed circle? It is open, and less than is to the left. So we're shading to the left of that point. So anything less than 10 would make this a true statement. This original inequality, I could pick any number less than 10 and plug it in for m, and it would be a true statement if you simplified it. Okay. Number 5 has x on both sides now. Okay, so when your variable is on both sides, we have to move them to the same side to combine them. But before I do that, I've got to get rid of these parentheses. Okay, so I've got to distribute this 2. So that is 6x plus 8. And then on the left, there was nothing to simplify. It's still 6x plus 3. So when I go to move my variable to the other side, I subtract the 6x. And the same thing that happens before on number 2 happens here. The variables eliminate. So I'm left with 3 on the left is less than or equal than 8. So no letters, again, they're eliminated. So I just have to ask myself, is this true? Is 3 less than or equal than 8? Is 3 less than 8? Yes. So this time it's true. When I'm left with just numbers, it's a true statement. So that means there's not no solution. The solution is all real numbers. That means any number could be plugged in for x up here, and it would be true. So far, so good. Now, on the number line, when it was no solution, we didn't shade anything because there was no value where it would be true. For all real numbers, we're going to shade the whole thing because it could be any number anywhere on the number line. Okay, let's try 6. Now 6 has parentheses on both the left and right side, so I've got to do distributing on both of those. So the negative 6 on the left gets distributed to the k and the 3. So that becomes negative 6k minus 18. And then we've still got our inequality of greater than. And then on the right side, I need to distribute the 4. So the 4 times k is 4k, and the 4 times -2 is -8. Now this time when I go to move my variable, 4k gets subtracted. This time it doesn't cancel out from both sides. So we've got a different scenario here. So we'll go ahead and just combine those. So -6 and -4 is -10k. And then we've got the -18 is greater than, and then just -8 is left on the right. Now the constant needs to move across, so that 18 is added since that's the opposite operation. What we do to one side, we do to the other. So that leaves us with -10k is greater than 10. And then to get rid of that coefficient in the front, I will divide. And since I'm dividing by a negative, what do I have to do? Switch the sign. That greater than flips and becomes a less than because I divided by a negative. So I ended up with k is less than -1. So on my number line, I'm going to plot a point at -1. It's going to be open. Since there's no or equal, what direction do I shade? For less than. K is less than -1. What direction is less than -1? To the left is less than. Questions so far? Are we doing okay? All right, 2 more like this, and then we're going to get into the application problems. We're going to apply this. Okay, these get a little more complex on the back, so stay with me. We again have parentheses on both sides, on the left and the right, and that we need to drop so that we can see what needs to move across the inequality. So this 5 needs to be distributed. 5 times 2y is 10y, and 5 times 3 is 15. Now on the right, there's nothing in front of these parentheses being multiplied. There's a plus sign. So I can just drop the parentheses. There's no distribution happening on the right side. But there are like terms that can be combined. So since I'm not distributing anything, I'm ready to just combine like terms. So I've got a positive y and a -2y. So that would combine to a -y. And I've got a +6 and a +2. So that would be +8. So I've got y's on both sides. I need to move to the left. So I'm going to add this y. So I've got 11y plus 15 is greater than 8. And then the constant is moved to the opposite side. So to the right, I'm going to subtract 15. So I'm left with 11y is greater than -7. And then to get rid of that 11, I'm going to divide. Now this time I'm not dividing by a negative, I'm just dividing by 11. So my inequality does not flip. Even though my solution over here comes out negative because it's -7/11, which we're just going to leave as a fraction because that doesn't divide evenly. It's not the fact that the answer is negative, it's the are we dividing by a negative that flips our sign, and we're not. So our sign stays greater than. Okay, the sign does not flip here. So we're ready to give that as our solution. Y should be everything greater than -7/11. And so we just have to remember that our point should be open because there's no or equal, and greater than shades which direction? To the right. Remember the arrow of the symbol is pointing. So it's pointing to the right. So we're going to shade to the right. Everything greater than. Remember, this is representing a number line, so the numbers get bigger to the right. All right, 8's complex just because of fractions, and I know some of us struggle dealing with our fractions, okay, but we're going to follow the same process. We're going to get rid of the parentheses first by distributing. So 2/3 is going to get distributed to t and 2. So it becomes 2/3 t plus, and then 2 times 2 is 4, so that's 4/3. Okay, on the right side, we need to distribute the 1/4. Okay, so 1 times 2 for the numerator here is 2. We can leave it as fourths, that's fine, because we're going to have to get a common denominator anyway, so we don't need to worry about reducing. So multiply the numerator, so 1 times 2 is 2, and our denominator is 4, and we have the t. And then 1/4 times -6, it would be -6/4. Okay, our inequality there is still just less than or equal. So now we've got t's on the left and right and constants on the left and right. So this is where we have to start moving those terms across the equation. So I'm going to move the t's to the left. Now, in our notes, when we did these, remember I came off to the side to show you all the scratch work of adding or subtracting fractions. Okay, if I'm trying to do 2/3 minus 2/4, right now 3 and 4 are our denominators and they're not the same. Okay, so to make them the same, we can multiply them by each other. So the 3 gets multiplied by 4 and the 4 gets multiplied by 3, they both become 12. Then they match. Okay, but when we're doing that, to keep our fraction proportional so that we're not actually changing the number, we have to do to the numerator the same thing we do to the denominator. So I'll have to multiply this numerator by 4 and this one by 3. Okay, so when I do that, that's 8/12, and that's 6/12. Now I have a common denominator, I just subtract or add the numerator. So what's 8 minus 6? So it's 2/12. Okay, so I'm going to say, all right, we've got 2/12 t. Okay, now I have to also move the constant, this 4/3 needs to go to the other side. So let me go ahead and do that. And we'll get common denominators and reduce that one as well. Oh my gosh, I don't know why that keeps zooming out. All right, so we've got -6/4 minus 4/3. Again, I want to turn the denominators into the same value. So I'm going to multiply this side by 4 and this side by 3. So that becomes 18/12, and the negative is still there in front, minus, and then this becomes 16/12. Now, because these are both negative, okay, it's -18 minus 16. Okay, so be careful with that. Don't accidentally just do the 18 minus 16. This term was negative. Okay, so what does that give us? 18 and 16, what are those together? Definitely going to be negative. And 12's our denominator. When we're combining two negatives, it's really, we know we're going to have a negative answer, but it's really adding those two values. So it's 18 plus 16. Anybody can do it. 34, thank you. Okay, so we'll just leave that as -34/12. And we've got our sign still in the middle. All right, so we got T's to the left, constants to the right. Okay, remember this is where I need to get rid of the coefficient. And you can do this in 2 steps. I've showed you all you can remove the numerator and the denominator separately, or you can do it at once. Because we can't divide by fractions in those 4 function calculators. Some of y'all prefer to think of it as 2 separate steps. Okay. So what we're doing is to get rid of this 2 that's being multiplied in the top, okay, you would divide both sides by 2. Okay, but I'm going to just write it as a fraction over here. And to get rid of the 12 that's in the denominator, it's the 12 is being divided, so the opposite is to multiply by 12. So 12 ends up going in the numerator. Okay, remember it's flipping that fraction. If I multiply, that's called the reciprocal. But when I flip that fraction, that lets the 12s reduce and the 2's reduce to give me just my t. So 12 over 2, you do to one side, you have to do to the other. So over here on the right, look at that again. The 12's reduce, and then I just have to do the 34 divided by 2. Which is 17. And this is a negative and a positive. So it comes out negative 17. So we had to do a lot of work with fractions, but we ended up coming out with an integer solution. So t is less than or equal to negative 17. Because of the or equal, what type of point gets plotted here? Solid. And then less than is to the left. So we shade to the left. So anything negative 17 or less would make this a true statement if you were to plug it in and evaluate. That's what this tells us. Any number less than negative 17 or exactly negative 17 would make this true. Okay, so you can work backward from that to check your answer choices if you have a multiple choice. Okay, sometimes that might be easier than going through all this with the fraction ones. I know the fraction ones are trickier. All right, so now the application. We've just got a couple application problems we want to try. Okay, I feel like this is where some of y'all were struggling in our practice last week. Okay, is coming up with the inequality from the words. Okay, so we want to underline, circle, highlight, whatever strategy you prefer to getting that important information turned into our inequality. So this says the charge per mile for a compact rental car at Dollar Rental Car is 18 cents. Mrs. Rodriguez is on a business trip and must rent a car to attend various meetings. She has a budget of $100 per rental for mileage charges. Write the inequality that could be used to find the greatest number of miles Mrs. Rodriguez can travel without going over her budget. So first of all, you have to know what a budget is. Having a budget of $100 tells us what? Can she spend more than $100? No, that's what the budget means. That word budget means that's her limit. That's the maximum she can spend. Okay? So if we're going to figure out how much she spends has to be less than or equal to 100. She can spend less than her budget, but she cannot spend more. She can spend exactly her budget. So we have the or equal. Now, how much she spends is going to depend on how many miles she drives. Remember, the question pretty much tells you what the variable is going to represent. Okay, to find out, we're trying to find out the number of miles. So the number of miles, that's going to be our X. And it's 18 cents per mile. So 0.18 times X, because you would multiply 18 cents times each mile driven to get how much she's going to pay. Hey, Christian, if you have we're going over the review. So if you have your review from Friday, you can get it out. If you don't have it, it's in the Friday folder hanging up there. All right. So now we've set it up. Guys, you don't need to start a conversation. We're in the middle of doing a problem. We've set up our inequality. How am I going to solve this for X? How do I get rid of the 0.18? I'm going to divide it. So I'm going to divide by 0.18. Okay, and you would do this in your calculator. Your 4-function calculator will do this. 100 divided by 0.18 comes out to 555. And then it's 0.5 repeating, so I'll just round to 0.6. So she needs to drive less than or exactly 555.6 miles. Okay, so we want to put that into words. We want it to make sense in this context. Okay, so she can drive up to 555.6 miles. Now the wording can be slightly different as long as it gets across that she can't drive more than that. She can drive up to that many miles, or your wording might say she can drive 555.6 miles or less. Okay, the wording does not have to be exact to this. It has to mean the same thing though. It has to imply that that's the maximum number of miles that she can drive. So you could write that. The maximum number of miles Ms. Rodriguez can drive is 555.6. Okay, so your wording may not be exactly the same as mine, but as long as it means the same thing, that this is the maximum, then you'll get the credit. All right, let's try this one. Sarah's a sales rep at an electronic outlet store. She needs to make at least $12,000 in weekly sales of a particular TV model to qualify for a sales competition to win a cruise. If the TVs sell for $555 each, how many TVs will she have to sell to qualify? All right, so let's start underlining, circling, however it is you want to do our important information. So the question is asking how many TVs? That's our variable, that's X. Okay, and it says she needs to make sales of at least $12,000. So her sales, whatever that is, can she sell more than $12,000 worth? Is that okay? It says she has to sell at least 12,000. So 12,000 is the minimum, right? So she's allowed to make more sales. I'm sure they would like that because it makes them more money. Okay, so the amount that she sells can be greater than or exactly $12,000. It cannot be less. She's got to qualify to win that cruise. That's the minimum amount that she has to sell. Okay, and her sales will come from 550 per TV. So, and we said the TVs were X. So it's 550X. So to solve this one, I would need to divide by 550 to get X alone. So 12,000, and again, your 4-function calculator will do this just fine. 12,000 divided by 550 is 21.82. If I round. Now here's the thing where it gets a little tricky. The mileage, you can drive 0.6 miles, right? You could drive decimal amounts of miles. But here, can she sell a fraction of a TV? Can she sell 0.82 of a TV? No, you're only selling whole values of the TV. So 21.82, really what she has to sell is 22. We have to round this. So she's got to sell at least 22 TVs. And if you're unsure if you should round down or round up, multiply that 550 by both. Say 550 times 21 and 550 times 22. And you'll see, if you're checking this, if you did this off to the side to check, if she sold 21 TVs, she would only have sold $11,550 worth. But if she sells 22, she'll have sold $12,100 worth. So if she sold 21, that's not enough to qualify. So you've got to round it up to 22. So my answer here is Sarah needs to sell at least, she can sell more, but at least 22 of the TVs. Okay, so you have to pay attention to the context of the problem if it makes sense for your answer to be a decimal or not. Okay, you can't sell a fraction of a TV, but you could drive a fraction of a mile, like in the last problem. All right, last one. David's goal is to maintain an average weight of at least 215 pounds during the first 4 weeks of his new workout routine. The first 3 weeks, he weighs in at 211, 214, and 221. Write an inequality for W, the weight, oh, the name changed here. I think that's just a typo. Sorry about that. The weight, that should be David, can weigh in at on the 4th week to have maintained his desired weight. All right, so let's think about this. He wants his average weight to be at least 215. So is he okay if it's higher? Yeah. So his average weight that we come up with, the expression for that, can be greater than or exactly 215. He just doesn't want it to be less than. So now what we write over here on the left is going to be how we find the average. And it's the average of 4 weeks. Okay, so remember, averages, you add up the values. So in this case, there's 4 of them. And you divide by how many there are, which is 4. So the 3 that we know are 211, 214, and 221. Let me write this a little neater. The last one's unknown. That's my X. Okay. We want to find out what his weight on the 4th week is. That's our X. Okay, so to solve this one, it's not just dividing a number over. It is simplifying the left side first. Okay, so to solve this, we got to move the 4 by multiplying. That gets rid of it in the denominator. And then in the numerator, I can go ahead and add all of these numbers up. They're all being added. So I'm going to use my calculator and I'm going to add 211 plus 214 plus 221. And I get 646. All right, I'm going to finish this one. I'll post the video and I'll post the completed. So you can check this one. You've got tomorrow to study. You've got Hat Tracks on Wednesday. Our test is Wednesday, study this review. Make sure you finish this last problem. Okay. This will be posted on our Canvas page. Y'all enjoy your day off tomorrow. All right, 215 times. That's 860.
No, you're not.
And then we would subtract this over to the other side.
The rest of you.
So that ends
No,
up
I wonder why.
860 minus
You spend the whole
646.
time screwing around,
214.
laughing, playing.
So that is the
No wonder you're
minimum
not
that he
happy.
needs to weigh in the
You
fourth
want to
week.
graduate or no? Then get it together.